Good morning, sir and madam. We, the team Innovation from CVR College of Engineering, has been applied for the Smart India Hackathon 2025, and we have came up with a solution which has been mentioned by the government of Kerala. The title as Solution for Non-Revenue Loss in Water Supply, Solution to Improve Awareness in Water Conservation, Treatment of Wastewater and Reuse for Domestic Purpose. And problem statement, the SIH ID is SIH25085. Our team ID is 73261. And this comes under the hardware category. And let us go deep dive into our PPT. So we title our product as Jal-Rakshak. So how it addresses the problem? Directly tackles all the issues in the problem statement, reduces NRW with hardware-based monitoring, promotes conservation through the reuse and awareness. So detailed explanation about our project. Flexible, inexpensive, that can be applied inside the pipes. Sensor can detect leaks by monitoring change in pressure and flow. Deploy dual pumping system unit for domestic reuses. Include a mobile app for citizen engagement and awareness. So some of the current methods. So what are the current methods, sir? For non-revenue water loss in smart water metering and leakage detection, but it high costly and requires skilled manpower. But our proposed solution uses a flow and pressure sensor connected to an ESP32 and GSM module at the ends of a pipe to continuously measure pressure. If abnormal pressure differences are detected, the system identifies leaks or overflow and immediately sends the exact location of the fault, enabling quick repair and reduce water losses. So current solution for the awareness in water conservation is government-led campaigns, but they have low public participation and short-lived impact. And our proposed solution consists a website which interface every user and also gives the ID for the every people who are living in a society, and also gives the awareness about the water and importance of the water. They can even continuously monitor the leakage and also get the awareness about the project and water. So current solution for the wastewater treatment and reuse is centralized sewage treatment plants, but they need high cost, large land, and continuous maintenance. Our proposed solution uses grey water from baths, kitchens, and laundry by using mesh filtering, grease trap, biochar tank, vermi-filter, and mini wetlands, and supplies the treatment water for the toilets, gardening, laundering, and floor cleaning. And some of the technology used are ESP32, which HTTPS and API, Arduino IDE, and Vogue WI, PHP web development. And sensor, our solution places flow and pressure sensor at the pipeline edges, which detects leaks and pinpoint their exact location using a GSM module connected to the microcontroller, enable quick action and reduce water losses. So what is our innovation is a comprehensive integrated approach with both hardware and software, low cost models suitable for the local context. And what is the evidence? We are providing a simulation link in this PDF, which will provide a valid information about our project. So technical approach. Whenever it comes to technical approach, first we can see a IoT system architecture for leak detection. So here the two flow sensors and two pressure sensor are connected with the microcontroller. This microcontrollers continuously monitor the values of the pressure and flow sensors. If any detection or any abnormal activities has been mentioned by this sensor, it immediately gives the information using GSM module and also gives the location where the detection and leakage is detected by mentioning latitudes and longitude of the sensor where they are placed. And this GSM module connect to the cellular network and also user, and also sends the information to the website which we have been created. So here we can see water conservation and awareness and incentives in the website. So this is the basic website which we have created, Government of Kerala. So this is the home screen after logging into your account. So here we can see the sensor data, sensor 1, 2, 3, 4, which has been calculated by the manual hardware system and sends the data to this sensor. And here we can see the leakage detection. If there is a leakage or no leakage. If no leakage, no location is available. If leakage is detected, the location is given to exact location slide at the time. At what time this values has been measured, we can get the exact time. And we are also mentioned some feedback and reward section here. So why this feedback network? Sorry, feedback system. If have any problem in your area, you can raise your complaint, and also after solving of your problem, you can give a feedback to us. That too, you will get definitely rewards by the government of Kerala. And third one is grey water treatment and reuse plan. So here we take the potable water line. After doing the grey water, normal water, we send this water to the mesh filter and treatment this water and store into the tank. If what happens, the pH value is greater than 7. If the pH value is greater than 7, we use it a treatment path pH reducer using vertiver glasses, and screening and grease trap, vortex biochar, vermi-filter, and mini wetland. And again, we check the pH and then we send to the storage tanks. So, what are the impacts and benefits? So, benefits of the solution is revenue can be saved by this project, and also for the social, we can widely use it. We can widely use and give the awareness to the people and environmental supports completely environment by providing a sustainable and efficient use and uses of the resources. Potential impact of the target audience. Kerala government. Reduction in non-revenue water and associated finance losses. Citizens. Potential for lower water bills and greater awareness of the water consumption. Environmental. Conservation of a vital natural resource and reduction in water pollution. So this is the feasibility of our idea. Our solution is technically viable using readily available sensors and low cost gray water treatment methods. So here we can face some of the challenges, that is inaccuracy due to impurities, and also need a regular maintenance of gray water treatment plants and possible GSM alerts. To overcome these challenges, we need to continuously calibrate and clean our sensor, and also gray water units are designed for easy maintenance. So let us watch a simulation of our project and code of our project. So this is the drive link which we have created for the simulation and code and documentation. So let us go for the animation. So this is the basic animation of our project. Here we can see this is the pipeline. These are the sensors placed. It gives a green light, means that no leak is detected. If the leak is detected, here we can have represented with red lights. And this information is interconnected with a microcontroller. And we are connecting all these solution locations to, and the sensor and microcontrollers provide the information in website, also gives a SMS or alert to the user. And database, how it works. So this is the basic website web interface. Here is the login credentials. After logging into your account, you will get interface like this: sensor 1, 2, and this is the code which we have developed. And this is a simulation diagram of our sensors. And after monitoring the values of the sensor, we are sending directly these values to the website, which can be reflected in user ID's account. So this is the basic process. Here we can see the values before the simulation and values after the simulation. No leak is detected. And thirdly, this is the block diagram of water reuse. So central water tank and also mesh filter. After this, we shade to the grease oil trap. After vertex chamber and vermi filter and mini wetland, then pH checker, then treatment of the water storage, and again to the reusement of the water. And this is a documentation for the website of the leak detection. So for the demo, we have used two dashboards. One is user ID and for one for the admin. User ID can only know the what is the exact location for the specific sensor, but the user can know all the sensor and monitor all the areas at a time only. And these are the research and references for this project. Thank you.